Today's topic is about functional dependency. So, what are the functional dependencies? Functional dependencies are the fundamental concept in database design and are used to establish relationships between attributes in databases. So, functional dependencies are basically the dependencies among the attributes of the relationship or table. So, what are the advantage of identifying the attributes? So we have a lot of advantages. We can identifying the dependencies is useful and help in normalization. So it is the step toward the normalization. So we can easily normalize the database table using functional dependencies concept. And it also helps to identify the super keys, candidate keys, and then primary key. So let's come to discuss the functional dependencies in more detail. These are the few properties that are necessary to understand before solving problem with functional dependency. The first property is if B is a subset of A, then A identifying B. Or we can say if attribute A is identifying B, so this means B should be the subset of the or B should belong to A. The reflexivity property say that every attribute identifies itself. For example, A will always identify A, B will always identify B. If we take example of student table and attribute student, so this means student ID will always identify student, name will always identify name. The second property said that if attribute A identify B, then AX should identify BX. This property is called augmentation. So if we take example of suppose A is a student ID and B is a address. So if student ID is identifying the address of that student, like we say if we know the student ID, we can easily identify its address. So if we take the attribute X toward both sides, so we can say for example X, we take X for example as a contact number. So student ID and contact number together identify address and contact number. So this property is called augmentation. Third property is if A identify B and B identify C, then this means A must identify C, and this property is called transitivity. Let's take example of suppose student ID identify student name and student name identify address. So this means student ID must identify the address. If A identify B and A identify also C, this means A is identify both B and C. So we can write A identify BC. This property is called union property. Suppose student ID identify name and also student ID identify address. So this means student ID identify both student name and address together. Another property is the composition property. For example, if A identify B and X identify Y, so these are two different attributes. A is a different attribute, X is a different attributes, and they identify the different attributes. So together we can combine the left side attributes and the right side attributes together. So we can say AX identify BY. Similarly, if AX identify BY, then using decomposition property we can say AX identify B and AX identify Y. So this is a decomposition property where AX can individually identify B or Y. Let's take example and solve the dependencies using these property. Relation, we have given the relation R, the schema R, with the following attributes A, B, C, D, E and F. Suppose these are the few relations that are given or that are identified from the table rows. These dependencies can be identified, can be identified from the data or can be given. Suppose A identify B, B identify C, C identify D, while E identify F and F identify E. So we can write A identify A. This is the reflexivity property because each attribute identify itself. A identify B, this is given in the scenario and problem. A identify C, this is a transitive property. If A identify B and B identify C, which is given, so this means A identify C here. So this is given transitivity property used from the given scenario. Similarly, using transitivity property, we can find A identify D. A identify E is not possible. Why? Because A have relation with B, B have with C, C have with D, but D have no relation with E. So this is not possible. If we look into these relations, we can write here A identify A, which is a reflexivity property, and F identify E, which is given. F identify E is given. So using composition property, A identify A and F identify E. So using composition property, we can write AF identify AE, and using decomposition property, we can write AF identify A and AF identify this E. So this means AF indirectly identify E, A identify A, and F identify E. So this means we can say F identify both A and E. So let's see. A identify A, A identify B, A identify C, A identify D, E identify E, and E identify F. This is a reflexivity property. E will identify E and E identify F is given. So if we take the union, because in the last slide you have already seen that if A identify A and A also identify B and A also identify C and D, so this means A is identify all the attributes A, B, C, D. This property is called union. Also E is identify E and F, so we can say E is identify E and F. This property is also called union. So from this scenario we have a set of these two relationship. Now if we apply the composition property, A is identify these four attributes, E is identify these two attributes. So if we take composition, so this means AE will identify A, B, C, D and E, F. So this means AE is the attribute, A is the combined or composite attribute. We can say the composite attribute which is identify all the relationships. So this means AE is the attribute. AE are the attributes which are identifying, which are together identifying all attribute as a composite. Similarly, AF will also because E is identify F and F is also identify E. So we can also say that if we, instead of E we take here F, because F identify F and F also identify E. So here we will write then F identify EF and then AF will identify A, B, C, D, E, F. So in similarly way, AF will also identify all the attribute. This means A lonely cannot identify all the attributes. A can identify only A, B, C, D, but it does not identify E and F. So A is not enough to identify all attributes uniquely, or we can say A attribute is not able to identify all the attribute or column values. So we must have to take some other attribute. So using these property we can easily find those attributes. Now closure is the, or we can say closure set. So from closure set we can easily expand the attribute or the combined composite attributes to relations that all comprise that relation. For example, this is the relation A, B, C, D. R is defined on the A, B, C, D, E, and these are relation given. A identify B, C identify B, D identify E, E identify D. These are the given relations. So we take the closure of each attribute or the composite attribute. So first we take the closure of each attribute. So we write here A identify BC. So the closure means how much it is able to identify all the attributes. So A is identify A, B, C, because A is identify A, that is reflexive property, and A is also identify BC, which is given. So this means using the union property, A is identifying B, A, B, C. Similarly, B is identify B, which is the reflexive property, but B is not identifying any other attribute, as we can see from the given scenario. C is identify C, as well as C is identify B as given. So using the reflexive property in the given scenario C, we can say the closure of C is CB. Similarly, the closure of D will be D and E, because reflexive property say D is all identify D and D is identify E as given. So D will identify DE, D will identify E, and here from given scenario we can say D also. So union property, by applying union property we can say E is identify D. So from this scenario we can say there is no attribute which can identify all the attribute A, B, C, D, E. So we see now we now combine the attributes. We take the composite attributes. So first we take the combination of two attributes together. We take the composite of two attributes. So first see AB. A will be combined with B. So A identify A, B identify B. This means AB identify AB and B identify A plus, from given scenario we can say BC. So A identify BC and B identify BD. So A identify A and A also identify BC. So from this scenario we can also say we can see A is identify ABC. So A is identify ABC, but B is not identifying any other attribute itself apart from itself only. So we have already written here B, so there is no need to repeat B again. So AB is identify ABC, AC is identify AC, and then B. We can see C is identify B. So AC will identify AC, and then C identify B. So AC will identify ACB. AD identify AD, and then D identify E, and E identify D. So AD will identify AD, AD is identify AD, and A is also identify BC from the given scenario. So add identify AD first and then add identify BC. So we write here BC and then D identify E. So together AD will identify ADBCE. Similarly, if we see AE, so identify AE identify AE because of the reflexive property. A will always identify AE, and A then identify BC from the given scenario. So we write BC, and then E identify D. So we also write D. So the closure of AE will become AEBCD. So in this way, similarly way, we can find the closure of the combination of these two attributes that are all possible. Similarly, we will then find the closure of the ABC, ABD, the combination of 3 attributes and then 4 attributes. So it is clear now that if AD can identify all attributes A, B, C, A, B, C, D, E, A, B, A, D, B, C, E. So this means if we take any other attributes with AD, for example, we take ADC, ADE, ABD, so it is obvious that it should also identify all these attributes. So these are the minimum number of attributes which are identify all the attributes. So in similarly way, if we take all the attributes, the composite of all attributes A, B, C, D, E, so it is obvious that it must identify all the attributes. So if we take all the attributes together, it must identify all the. So this was all about the closure. So why we solve problem with the closure? In order to identify the super keys. So super key is any subset of attributes which can uniquely identify each record, or we can say any set of attribute, any set of, we cannot say any set of minimum attributes, but we can say any set of attributes. There can be 2, 3, 4 which can uniquely identify each row, or we can say which can identify all the other attributes, all the attributes of this relation. So AD is a super key here because AD identify all the attributes. A is a super key, A, B, C, D is a super key, A, D, this is a super key because CD is AD also already cover the all attributes. So it is obvious that A, B, C, D must identify all the attributes. So in one relations, in one particular relation, we can have many super keys. So the possible number of combination from the relationship can be found using this formula 2 raised power n minus 1. Here n are the number of attributes. Here the number of attributes are 1, 2, 3, 4, 5. So this means 2 raised power 5 minus 1 is equal to 31. The total possible combination or closures will be 31. And there can be many super keys. Laterally in next slide we will see, you will see how we can identify the candidate key for the primary key. These are other examples you can solve by yourself. Relation A, B, C, D, E, identify B, C, C identify D, B, D identify E, E identify D. So the maximum relationship combination of closure will become 2 raised power 5 minus 1, that is 31. And you can apply the above properties, reflexive property, union property, composition and decomposition property in the given scenario. You first will find the closure of each attribute individually, and then you will take the composite attribute together. First you will take 2 attributes, and then first you will take 2 attributes together and find the closure, and then 3 attributes, 4 attributes, and at the end we will take all the 5 attributes, that is only one combination, and then you can easily check what are the possible super keys that are identifying all the attributes. Similarly, this is another example: A is identify B, B is identify C, and D is also identify C. This is a solved example where the relationship attributes are V, W, X, Y, Z. These are the super keys already find it. V, Y is a super key, V, Z is a super key, and similarly all the super keys V, W, Y, Z, X, Y, Z, V, W, X, Y, Z. So these are all the super keys already find it. So this means these composite attributes are identified each record. Size of the super key is the number of attribute in the super key. So the size of this super key is 2, this is 3, and this is 5, and this is 4. So the size is can be calculated from the number of attributes. Similarly, candidate key. Now, candidate, as the name show, candidate. Candidate means we will then select the primary key. Primary key is the unique identifier which can identify all the attributes. So it can be one attribute or it can be the composite attribute, but it is obvious that primary key should be from the super keys. So there can be multiple candidate composite attribute or attribute possible for the declaring it as a primary key. So there can be multiple candidate attribute possible. So what is the candidate key? Super keys with the smallest size. So super keys with the smallest size. So we can see the smallest size here is Vy and Vz, 2, because there is no single attribute in the super key which can uniquely identify all the attributes. So the minimum size is 2, so which is Vy and Vz. So we can select, so these are the candidate keys, and we can easily select any, we can take any composite attribute from these candidate key for a super primary key. The primary key can be Vy or Vz. These are the other example. So find the candidate keys in the following. This is for you. Solve these in your home. R, identify A, B. R is defined over A, B, C, D, E, and these are the relations. So these are the relations given. Try to solve, and using the properties, using the closure, apply the closure rules, and then find the super key. And then based on the size of the super key having the minimum size will be selected in a candidate key, and then you can easily select candidate primary key from the candidate keys. See the example R. Define over A, B, C, D, E. A, B identify C, C identify E, D identify A. To find all the super keys, we need to check the closure of 31 combinations. Find all the candidate keys. First, we will solve the dependencies using by taking closure of all attributes and composite attributes. Then we will find a super key and then candidate key. So if we see identify A, B identify B, C identify C, and also C identify E, D identify D, and also D identify A. So D will identify DA, E will identify E. So these attributes are not enough. The individual attribute as we see from the closure are not enough to identify all the attributes. So these cannot be super keys. We can then take composite attributes together: AB, AC, AD, AE, and BC in similarly way. then we will move toward the combination of 3 attributes, 4 attributes, and then one time 5 attributes together. So you can see BD is the only composite attribute which is capable to identify all the attributes. BD identify, you can see BD identify BD. Then we can see BD identify BD, and then D identify A as given from scenario, and then AB inside these 3 attributes identify C as given. So BDA will identify BDA, BD will identify BDAC, and then C identify E. So we will write here E. So from inside we will consider all the possible dependencies as given in the scenario or by applying any rule. So in this way you can take the closure, and then the super key, this is the super key, BD is the super key, and then if we combine any other attribute, we take any attribute with BD, it will also become super key. ABD, CBD, EBD, similarly ABCD, ABDE. So we can have many super keys, but this one is the candidate key. Why this is the candidate key? Because this is the size of this super key is 2, and we have solved all the we have solved it for the 2 composite attributes together. We have left the 3 composite attribute closure and the 4th. So because it is clear that candidate key is now from these attribute, which is the BD. So BD is the candidate key. There is no possibility of other candidate key because the closure of 2 composite attributes are here. You can see. So BD is the candidate key as well as primary key. You can see this one relation. R is defined over W, X, Y, Z, and these are the relation. Z is identifying W, X, Y, X is identified W. So W is identified W, X is identified W, X, Y is identified Y, and Z is identified W, X, Y, and X is also identifying W, but Z is also identified itself as from the reflexive property. So this means Z is identified W, X, Y, and Z. This means Z is the candidate key. So it will be the only default primary key. So the candidate key and primary key both will be the Z. This is another example. R is defined over A, B, C, D, E. These are the relations. A is identified C, C is identified B, B is identified D, D is identified E. So this means A is identified A from the reflexive properties. A is also identified C, C is identified B. So A will identify A, C, B, D, and D. So A is identified A, B, C, D, E. This means there is no need to take other closures. So if we take a combination of, if we take the composite of the 2 attributes and then 3 attributes, 4 attributes, we will have multiple, not multiple but too much super keys, but this will be waste of time. So because the candidate key is already here, A, which is A, so this A will be the candidate key, and then it will be also the primary key. So primary key will be then imposed on the attribute A. Similarly, this is another relation. A, B, C, D, E. A identifies C, E identifies D, B identifies C. So this means A, B, E is the candidate key. This is already solved, so you can solve it in your homes. It will be better that you solve by practicing it. So A, B, E will be the only candidate key. For example, if we take the closure of all single attributes, then composite attributes of composite of 2 attributes and then 3 attributes, 4 attributes, 5. So this is the minimum size attribute, composite attribute, which is identify all the other attributes. This is another attribute. R is defined over the v w x y z in a given scenario. Suppose z identify w x y, x identify w, y identify z. So by solving this, so these two are the candidate keys that are identified. So super keys, from the list of super key you can then identify all the candidate keys, and then from candidate key list you can select any composite attribute, or if it is single attribute, so it will be the primary key, or if it is not single attribute, so we will then take the composite attribute with the minimum size. So these are the two attributes, composite attributes with the minimum size, that are identify all the other attributes. So we can either select Vy as a primary key or Vz. Option is on you. These are other examples. A identify C, C identify B, B identify D, D identify E, E identify A. So this is an interesting scenario. Each attribute is identified other in the cycle, like A C, C B, B B D, D E, E D. So if you solve all these by using the closure property, so all the attribute will be declared as a candidate key attribute. So because A is identified A is identified C, A is identified B, A is identified D, from reflexive property, if you solve indirectly we can say A is identified A, B, C, D, E. B is also identified B, then D, E, A is identified C, and C is identified B. So this means B is identified B, D, E, B, D, E, A, and C. Similarly, D is identified E, E then A. So this means D is identified D, E, A, C, B. So this means all of these attributes are the super key as well as the candidate key and as well as the primary key. So we can take primary attribute on any of these attributes. But remember that this is the property or characteristic of primary key, that we can have only maximum of one primary key in the table. It can be, as you can see from this lecture, it can be on the multiple attributes, or we can say composite attribute, but the primary key will be only one. We cannot take both A and B as a primary key. This is a choice. This is a choice that we select A for primary key, or B or C or D or D, E, but we cannot then choose all the candidate key for the primary key. This is another example which is solved here. A, B, C, D, E up to J, and the relations are given. If you solve, you can easily find these two candidate key, A, J, B and A, G, E. So these are the minimum set of attributes or composite attributes which are identify all the attributes A, B, C, D up to J. So now come to discuss what are the prime and non-prime attributes. Prime attributes are any attribute that appears in the candidate key. Remember the candidate key. So those attributes which are in the candidate key will be the prime attributes, because, or we can say, this means these attributes identify other attributes. So the dependent attributes will be non-prime, any attributes which are not in the primary attribute. So means A, J, B are the prime attributes, A, J, E are the prime, and these all in this example, above example, A, B, C, D, E, all are the prime attributes because they all identify others. So this is another example. A is defined over A, B, C, D, E, F, G, H, and these are the dependencies given. If you solve this example, you can easily see, you can easily solve the you can easily calculate find the candidate key, so it is calculated. So you can solve it by practicing it at home. In next lecture we will start the normalization, so we will discuss how these dependencies are helping in normalization. So let's wait for the next video. Thank you so much.